Hi, and welcome to my talk in the Powerful Visualizations track at this year's Notes. The track title is a perfect fit for my presentation, which focuses on creating helpful and meaningful visualizations. I hope that after my talk, many of you will realize that what they've known as graph visualization before was only the tip of the iceberg. I want to illustrate what makes graph visualizations truly awesome and powerful. Naturally, I'll provide insights on how you can create these from the data stored in your Neo4j graph databases too. We'll explore different tools, ranging from no-code and low-code to full-code solutions. But rest assured, you don't need to be a programming expert to craft exceptional visualizations. And for some of the more challenging and time-consuming tasks, we'll leverage various forms of AI to make our lives easier. But first, let me quickly introduce myself a bit in more detail. That's me, Sebastian. Now, I've been working in the field of graph visualization in my role as CTO at yWorks for more than 20 years now. And visualization is what we focus on at yWorks. Our tagline is the diagramming experts, and I hope that I will be able to show you why this is actually a good fit. Check us out on the internet and social media. There are multiple tools and products related to Neo4j graph visualization available from our website, and most of them are free to use. And this is our agenda for today. In the past, I had a lot of text on this slide, but I think this illustration pretty much says it all. Everyone knows these visualizations on the left, which are fine for some use cases, and sometimes there is no need to improve them. But there are many cases where the data in our graph databases can benefit massively from a more sophisticated visualization. And as we'll see, when we enhance the visualization, we can provide our users with a much better experience. The exact benefits depend on both the user and the user story, of course. After all, it's the users looking at the visualization, asking questions and looking for answers, or maybe trying to gain new insights. We'll be touching different use cases, and we'll see what makes graph visualizations more powerful so that users can benefit more from them. And of course, I'll show you how you can create those awesome visualizations too. Note that the visualization on the right is just one example for a use case that has been created with our tools. Now let me quickly give you an overview of what these tools are and how they are connected. So look at that third column. These are the main tools that I'll be showcasing in this session. They are readily available for you to use, so there's not only are they free, but they also don't require registration or installation. The third tool is a plugin for Jupyter Notebooks, so technically it does need an installation within a Jupyter environment, but nevertheless, you can use it with your cloud provider, for instance, on Google Collaboratory, and begin working immediately, even on your tablet or mobile devices. Some of you might have already be familiar with these tools, and in past Note conferences, I presented earlier or preview versions of them in greater detail. So if you're curious, feel free to explore the Neo4j YouTube archives for more information. And specifically for the data scientists of you, check out my talk from Notes 2022 about the Jupyter Graph Visualization plugin. I won't be discussing it in today's session at all. So what's new this year? We've introduced a plethora of exciting features, and at yWorks, we've also embraced the AI revolution, of course. We discovered impressive applications in the realm of advanced diagramming. We've incorporated large language models, integrated both natural and spoken language interfaces, all to significantly enhance the user experience. Moreover, we're leveraging the boundless creativity of ChatGPT to assist in both the design and implementation of powerful graph visualizations. I'll delve deeper into this topic later. A commonality among all these tools, and indeed any graph visualization you'll see in this presentation, is that they have been created with the help of our programming library yFiles, which is the software development kit that we have been building all along at yWorks. All the tools that we'll be looking at run on the web platform, and Neo4j has a connector for communicating with Neo4j databases on that platform too, of course. If you want to try out what I will show you today with your own data, in order to get started, everything you need is credentials for your database, and read access will actually suffice. With the Neo4j connector, our apps can connect directly from the running browser application to the database. This means your data never leaves your systems or touches our servers. You can run these tools offline, disconnected from the internet or from behind a firewall if you wish to, and you don't need to expose your database in any manner. I encourage you to give it a shot. Okay, so why should you consider yet another set of graph visualization tools? What sets these visualizations apart as powerful and worthy of your attention? Why choose our tools or even our commercial software library over other available options? The answer is simple. Our tools enable you to accomplish tasks that most other tools cannot. With our diagramming library Y-Files, you can craft powerful visualizations that are precisely tailored to your specific use cases. Now let me present some examples of what we believe defines a truly powerful graph visualization. Let's begin by examining the visualization of various elements in a diagram. Nodes are not restricted to being represented by just simple geometric shapes, and relationships in a diagram aren't limited to straight lines. Often, there's more information associated with these elements than what a labeled circle can actually convey. So why not display that information directly within the diagram? You can use level of detail rendering or show more details as a user zooms in on the diagram and simplify this visualization when zoomed out. You can present the essential information directly inside the node or along the connections. To facilitate instant recognition, utilize features like gauges, icons, progress bars, images, and even embedded charts or interactive UI components. And if there's additional helpful data outside of the database available, you can augment the visualization with information from other sources too. You might even integrate live data in your visualization. You can apply many of these visualization techniques not just to nodes, but also to edges and even labels. Often, I notice that many don't realize this next crucial point when they're about to visualize elements from their graph database. There's absolutely no requirement to depict every node as a box or circle in your diagram, nor every relationship as a line connecting these elements. In reality, the database schema might have already been optimized to work seamlessly with its original data sources, or it might have been custom designed to support and optimize particular database queries. Consequently, the implicit schema in your database might not be the most suitable one for visualization. Moreover, remember that efficient visualization tools can do much more than merely draw boxes and lines. You should leverage these additional capabilities to enhance the visualization's accessibility. Consider the following. Some relationships are better left unpresented as lines. For hierarchies, expressed as relationships or node properties in the database, consider techniques like nesting nodes recursively. Here, the hierarchy gets visualized through containment, significantly reducing clutter from the diagram. Depending on the use case, sometimes it can be more intuitive to display shared property values as connected standalone nodes. There are often instances when showcasing transitive relationships, which aren't explicitly in the database, provide the insights users seek. And again, they enable us to reduce the amount of unnecessary noise in the visualization. At times, it's beneficial to group multiple relationships into one or a few edge bundles, enhancing the diagram's readability. So, embrace the idea that visualization doesn't necessitate a direct one-to-one mapping from database elements to visual elements. Remember, altering the storage or the implicit schema in your database is not mandatory. These transformations can easily be accomplished at the visualization layer. Also, please don't assume that merely placing nodes close to their neighbors on the screen is sufficient. The placement of nodes and the routing of connecting lines can encode a wealth of meaning. If that meaning is important for your use case, you should present it clearly. When your items belong to different categories and those distinctions matter to your users, factor that information into the layout and put items of the same category closer together, or even apply an extra layout to them. When there's a flow in your data, emphasize this flow across the edges using directed layouts. If your data contains hierarchies, present them in a manner users would typically expect them, often top to bottom, for example. Move start nodes and end nodes to the respective sides in the layout to help the user quickly see entry and exit points. With advanced automatic graph layouts, you can specify many different constraints that assist in highlighting details, clusters, subgroups, outliers, dependencies, and so on. And a sophisticated edge routing allows users to see the connections, even if there are many of them. Use bundling for the edges if there are too many edges, but make sure the user can identify those connections when they are interested in. You can even consider utilizing multiple layout algorithms with varying configurations to emphasize different facets of the data that the user might be interested in, and then animate smoothly from one layout to another, allowing the user to keep their mental map of the data. Next topic. So what's behind your graph visualization in the background? Is it an empty canvas? The background doesn't need to remain blank. For instance, when relevant, place your nodes within a table with defined rows and columns. Alternatively, organize them into parallel swim lanes to convey useful categorical information. This can be more effective than merely representing that information as a textual property or adding yet another node and connection. Even scalar data can be effectively visualized using things like heat maps in the background, for example. You may also render the outcomes of graph algorithm runs into your background visualization. You can use centrality measures, shorted path analysis, clustering results, dependency analysis results, and embed that information in the drawing. Also, things like grouping information, different types, or category details may be seamlessly incorporated into the backdrop. And lastly, if geodata is important to your audience, you can of course position nodes on a geographic map too. Therefore, think twice before leaving your background empty in the visualization. Okay, now let's discuss the most important aspect. While static visualizations have their merits, the complexity we often see in graph database use cases necessitates the addition of interactivity to enhance the user experience. Proper interactivity not only makes for a more powerful visualization, but also significantly enhances its utility. Certain interactions are fundamental to aiding users in data exploration, searching for elements, selecting them, displaying details, and providing tooltips. However, interactivity's potential extends beyond these basics. It can be harnessed to let the user interactively explore features of the network. For instance, to identify bottlenecks in supply chain networks, conduct root cause analysis, or interactively view upstream and downstream elements in a larger flow. Techniques like fading out, filtering, and drill down are invaluable when focusing on a graph subset. And we haven't touched upon the possibilities when you start to let the user edit the graph. While often graph databases are explored visually, of course, you can also use graphical editing capabilities to play back changes and populate your graph database. Many of these methods assist in reducing complexity and keep the user from having to untangle the hairball. For large graphs with interactivity, it's possible to drill down and simultaneously employ multiple views of the same data. For example, we can add separate neighborhood views, detailed views of the graph, or of the user's currently selected elements. And last but not least, make your visualizations easily accessible and, when helpful, deeply integrated into the workflow of your users. When a particular user story frequently arises, it's worth investing in a highly interactive and specialized user interface, tailored to address the specific needs of your users most effectively. Don't force your users to toggle between apps when you can consolidate the information and functionality within your visualization. Minimize unnecessary clicks and additional steps. Allow users to perform actions or initiate other apps directly from the visualization itself. When applicable, instead of developing a new application, consider integrating the visualization into existing apps dashboards, or even into notebooks. Align with the corporate design and interaction protocols to ensure your users feel immediately at home and confident. But isn't this a lot of work? Creating helpful visualizations like those in the previous slide certainly requires attention to detail, plus ideally a good knowledge of the business domain and the various user stories. We need tools that help us build these custom-made experiences. Let me show you what yWorks provides and how we integrated AI and generative technologies to assist developers and users with their tasks. We start by looking at our Data Explorer for Neo4j. At its core, it's a visual database exploration tool, not unsimilar to others that you may have seen today. Except, like I said, that it requires no installation and works from your browser, so it can safely connect to your database even from within your intranets. Other than that, it also offers some visualization superpowers. Since this is an exploration tool, the most obvious thing to look at is the interactivity. I won't go very much into the details here, but I will show you how to interactively drill down through your data with the assistance of an AI. Now, this is the Data Explorer interface, just loaded from our website. For this example, I connected to the movies database example that some of you probably already know. The movie database example has a very simple schema that consists of the persons and how they are related to movies. Persons can be actors, directors, and so on. And in the schema, we can also see that there are some properties associated with the elements. So let's start exploring. I could use regular search dialogues, but this is the first place where we'll be using the power of AI. Here, I can even use my microphone to enter my database query using natural language, spoken language. The Data Explorer will create the query for us and execute it. I'm searching here for the actor Keanu Reeves. Data Explorer listens to me speak, checks the schema, creates the query, and executes it. And we found Keanu. But we can do also more complex queries that involve our current browsing context. In this case, the selected elements in our visualization. I want to load movies that were released in the 1990s where the selected actor appeared in. This works. Now I want to load all the movies that have the word Matrix in their title. And here we go. This could all be done manually too, of course, but this is much more convenient this way, I'm sure you will agree. Take this query, for example. Load actors that appear in all the selected movies. Would you know how to write the query? Writing Cypher queries for use cases like this may not be extremely difficult, but it can become more difficult quickly. Let's see how ChatGPT is used under the hood. Let's see how ChatGPT, which is used under the hood, can deal with a more complicated and a powerful query. For this one, we'll look at graph transformation and projections. For example, when I'm interested more in which actor co-acted with another actor, I might not want to see the intermediate hop, the movie where they co-acted in. Remember that in the database, there are only connections between actors and movies, but there's no direct connection between co-acting actors. So let's see how the Data Explorer can help here. For this, we use the transitive edges feature of the Data Explorer. First, let's get rid of the older results. And now, without changing the database, back in the schema view, we can simply declare a transitive multi-hop relationship from actors via movies and back to actors. And thus we define a new co-acted in virtual relationship. Data Explorer now understands this new type of relationship that's implicitly available with my graph. In my diagram, I select Keanu, and I can now directly explore the new transitive relationship via the regular UI. And in this case, this gives me a lot of results. Again, instead we can ask the AI to create a more complex query for us with a nice filter applied. I want to find the co-actors of Keanu who appeared in the Matrix movies, but without showing the Matrix movies. This time I go via the menu to let ChatGPT create the query for me. Unfortunately, when I tested this, this time it made a slight mistake and messed up some variable names. However, in this UI, I can fix the query and execute it. So there's just this M over here wrong. And once I fix the query, I can execute it and then load the results into my diagram. So, and to prove to you that this works, as a last test for AI's Cypher capabilities, let's again find those movies that my co-actors co-appeared in, but only those where at least 3 of them appeared. This is a rather complex query that uses the context of our diagram. And this time, let's see how ChatGPT manages to do this. I enter the query and then let the AI create the query. And this time it actually works. So as you have seen, you can use this tool to author and test your Cypher queries too. They can be copied to your own notebooks and programs and so on. And we'll use this later on too. So now that we've seen how to interact with our database in the Data Explorer, let's take a look at the visualization of the items. We'll try to create different visualizations for our nodes, and we'll see how the AI can help us with this task. For the styling, let's look at a more complex example. This is a database that contains fake patient data. It has lots of information about patients, what encounters they had at what organization, and all kinds of attributes for these encounters. When I explore the data set for the first time, you will see that there are very basic visualizations used. We only get to see basically the labels and some type titles. But there's more information available with all these elements, like we can see here. So I can go to the styling panel and add a template for the specific type of label, in this case, the patient. So I'm adding a label, specifying a template, and I specify the label for which to create a nicer template. And when I click this button, an editor opens up, and I can drag and drop the properties onto the template. Like just in this case, we can use the address, for example, and we can also take first, which probably is first name. And we can also add things like, I don't know, for example, the gender, and even add the birth date, which we see is actually a nested property. So there's actually 3 properties that we have to put into the template to get a nice formatting. This is tedious. This is super flexible, but it's quite tedious. You can do all kinds of things like add prefixes, change the way the values are displayed, and add additional labels, additional static texts, change the colors, bind them to values, even add shapes to the visualization. They could be data bound too, or icons. That's all worth it if you spend a lot of time in it, because you get a much better visualization. But it's quite tedious to do, and sometimes we need to do this quickly for many different templates. Generative AI to the rescue. The AI template generator, which we have in this button, will go and inspect the names and the types of the properties, determine which ones are important and how the information should be presented. It will automatically come up with formatting, proper names, and even icons to make this more accessible. Once we use this template, you will agree that this looks much nicer. We can do this for the other items as well. There's even a shortcut that will generate the template directly for me. I just select the encounter and then hit the shortcut button. It will generate the template, come up with a nice visual presentation, and then we're done. And I prepared more templates and saved them so that I can share them with my colleagues, for example, because this is all running locally on my system. And of course, this can be loaded back into my view to finally apply a nicer layout. And this is my much improved visualization. So far, so good. We haven't covered yet rendering canvas backgrounds and showing additional information. And with regards to interactivity, there's actually more than what the Data Explorer has to offer. So let's check this out. Okay, here we have another set of patients along with encounters and organizations. And if we look at the data, note that there's geolocation stored with each of the patients. So we can go back to the schema view, select the item for a patient, and in the properties list, we can mark the location as geodata for use in a map view. The same works in organizations too in this data example. And back in the Explorer view, we can now start the map view. This loads a map and places all the nodes onto the map at their geolocations, except for the encounter nodes for which there's no map location available. But we can use the lens functionality to reveal this additional information dynamically. This helps us unclutter those areas where the elements overlap due to their geographic closeness, and shows the ones for which there's no geographic information available. Data Explorer still is a rather generic tool, and there are lots of advanced visualization use cases that are not supported by the Data Explorer yet. We haven't covered more sophisticated backgrounds, custom-tailored interactivity, and of course, no integrations. Luckily, there's a convenient escape hatch for software developers, and that is the so-called app generator. The app generator is a low-code tool for scaffolding source code of visualization apps and reusable components. So let's use it. All I need to do is use the export to app generator feature. This will take the configuration I created with the help of the AI and open it in the app generator. I'm not going to explain in detail how this works in this presentation. I'll just speed run you through until we have our first application. We see that there's a place where the query is specified, and all the other configuration items basically contain the styling information that the AI created for us. So now I'm just hitting the play button and execute a preview of my app. Now I can hit the export button to create a source code bundle. Here, I'm specifying that I would like to create a React app with React components using TypeScript, and along with some application features that I want to use in my resulting visualization. So we're going to use the context menu, we want to see an overview, interactive editing, tooltips, and so on. So then I hit the button and the zip file will be downloaded. And after extracting it, I can open the project in my IDE. And all that's left to do is just two more simple steps. I need to, as with every web project, need to install the dependencies using npm install. And then once it's done, start my development server, which is a Vite.js server in this case. Then open the app. And here we have our graph, dynamically fetched from the database using our AI-generated templates. And I could easily embed and reuse custom Cypher queries created with the help of the AI too. As a software developer, you now have a running visualization app or a component that you can add to your programs. Chances are, though, that I showed you some examples for powerful graph visualizations that you would like to use in your visualization too, but neither the app generator supports them or they aren't available in the Data Explorer. But this doesn't mean you cannot have them. You can reuse the source code of the hundreds of demos that come with our library. Let me quickly show you how I added the heat map feature for the generated app with just one line of code. So I want to add the functionality from one of the Wi-Fi's demos to my app. I go over to my package, which comes with all of these demos. I search for the heat map features, which is part of the process mapping demo, which you've seen before. So let's check the demo. This is the one, and I want to have that heat map in my graph visualization. So I locate the file in the demo that encapsulates that feature. And all I'm doing is copying it over to my application. That file has a single entry point exported, and that is a function called add heat map. So there it is. So from my application, I first locate where there is the Wi-Fi's graph component API. In this case, it's wrapped in some React component. There it is. I can call this function, and I need to tell it what values to use for the heat map. And in this case, I'm using the Neo4j properties object, which is attached to all the nodes in my visualization. And this one contains the claim cost from the database as a property. I'm normalizing it because these values are actually quite large, and they should be in a lower value range. So hitting save, and my application already adopted the change and shows the heat map values. Isn't it great? And of course, there are features that are more complicated to add and to configure, but we really try hard to make functionality available as easy as this. I hope this gives you some inspirations for your next visualization project, and that I was able to show you how AI can help with that. We've seen the benefits of using tailored designs for our nodes and relationships, how we can use the power of sophisticated layouts to encode information into our diagrams, how interactivity can make a difference and turn our visualization into a useful and powerful tool, and how integrating the diagram or the graph visualization into our users' workflows can boost their productivity. By now, we can let the AI do some of the design work so that we can see the data in meaningful ways more quickly. Large language models can help us navigate our graph database and create queries both for use in the Data Explorer as well as in our custom visualizations. At yWorks, we're continuously working on teaching AIs more tricks. For example, to do more of the integration work, choose the right layout, and so on. So do stay tuned. But even today, I'm eager to see what you will build with our tools and your data. Create awesomely powerful visualizations from your graphs. I just showed you how. So with this, happy diagramming with the yWorks tools and the software libraries, and of course with Neo4j. Thank you.
So hello everybody, welcome to my presentation. Today we're going to be looking at LLM powered dashboards. So the title is quite long, but what it really means is using LLMs to create Neo4j dashboards with human readable text. And we're going to be using NeoDash for that. So there will be a quick intro, then a bit of a demo, and hope to squeeze that into half an hour. Right, so who am I? So my name is Niels. I work for Neo4j now for almost 4 years. Working in the professional services team. And what my team does is we build full stack Neo4j applications. So we help our customers go from their very first prototype to a completely production ready system. And this could involve many things, and visualization is one of them. And that's the reason why I'm involved with NeoDash. So this is a project, NeoDash is a project that we've been working on for almost 3 years now, and it's been a really nice journey to work on a visualization tool and kind of help out the people that use Neo4j to make their graph visible. This has been a big team working on this. It's an open source project, but I just wanted to give a shout out to the other core contributors here. So you see their pictures on the screen: Jacob, Bastian, Marius, Alex, Alfredo, and Harold. Thanks a lot for all your work. It's been really fun working with you on this one. Good. So jumping right into it. So I don't want to go very deep into NeoDash today because the focus is really on these LLM powered queries. But just to give you an idea, if you haven't heard of NeoDash before, it's a dashboard builder for Neo4j. And what does that mean? It gives you a tool to very, very quickly build a dashboard with graph visualizations, tables, bar charts, maps, all kinds of visualizations on top of a Neo4j database. So what we often see working with Neo4j is that you want to visualize your data as a graph because you're obviously using a graph database. But a graph is not always the only visualization you need. You might need to have a table next to it, or a bar chart, or other things. And visualizing a graph is much more than just a graph visualization. It's having all these things together, interlinked to create this kind of nice demo. And I've got a screenshot here with all the kind of stuff you can do. Good to know about NeoDash is that it's a Neo4j Labs project, which is kind of the incubator for new tooling in Neo4j, which means that it's open source, but there's no support like we have with our product supported features. It's free to use, but yeah, open source and yeah, community, a real community project. I think that's the best way to put it. Good. So NeoDash, what can you do with it? As I said, you can create an interactive dashboard with visualizations, but it's also an extendable tool, which means that you can add in your own plugins or other people's plugins and make it a more powerful dashboard. So some of the stuff that you can do, you can add in your own custom visualizations. You can add in custom logic, which is the interactivity that I talked about earlier, or even like custom styling and this rule-based styling that you have in Bloom as well. But today I want to talk about the fourth official plugin that we've written for NeoDash, which is the text to Cypher translator. And this is where the LLMs come into play. This has been a lot of work. And again, this was mainly the brainchild of Alfredo and Alex, who you saw in the slide earlier. So thanks again, Alfredo and Alex, for letting me be the one who presents here. But it's been a lot of work from the two of you. Text to Cypher. Yeah. So what does that mean? I call it a translation. It's really a translation of a human question, a natural language question, into a Cypher query. So you can imagine a graph with movies and people, and you can write a question in English. Show me all the movies in which Tom Hanks played, and then using an LLM to convert that question into a Cypher query. Now, this sounds like magic, and it is very close to magic. I don't know if it's a science, but it's more of an art. And there has been a lot of really nice work done on this. So these are just some of the blog posts that you can find on the Neo4j developer blog. The work by Thomas is absolutely amazing. If you're interested in using LLMs for this kind of stuff, highly recommend to check it out. So we've honestly learned a lot from these and based many of the work that we did in NeoDash based on the work from others. So what does it look like? This is the UI in NeoDash, and you will see this in the demo later. And it's really quite simple from a UI perspective. You have a box in which you can write a question. In this case, a graph of all people who acted in the matrix, similar to what I just said, right? This is a human readable question. Then the LLM using some smart prompt engineering, can convert that for you into a Cypher query. So completely valid Cypher query using the labels and the relationships in your graph and the properties of the nodes. And then finally, directly visualizing that in a tile on the dashboard. So it could be, again, as I said, a graph or a table or whatever. But it's really quite a simple process. And you'll see this, you can very quickly start prototyping these dashboards with these queries. Now, the traditional way to use NeoDash was always to use Cypher, but this is just an extra step or an extra feature that you can do before writing the Cypher, converting that into a Cypher query with natural text. And I said there's some prompt engineering tricks going on under the hood. So I just want to very high level talk about what's the magic underneath, the secret sauce in this plugin. And it's really a combination of many things that we feed to this LLM to be able to generate the best possible Cypher. Starting with a task definition. So this is where we say to the LLM, hey, pretend that you're a Cypher expert, generate a Cypher query, blah, 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 blah. We give it the user question, so the text that I just wrote earlier. We give it the database schema, so we tell it these are the labels in your graph, these are the relationships in your graph, these are the properties on the nodes and the edges. So we give that to it as well, so it's able to understand that if I talk about a movie, I'm talking about a movie label in my graph. And then finally, we're also giving that query examples. So we're telling it, for a table, you need to generate a query that looks like this. For a graph, you need to generate a query that looks like that. And really bundling this all up and combining that into this prompt, sending that to the LLM, generates a really nice Cypher query. Good. So now we get to the fun part because we're going to try this out. So one of the things that I really enjoy in my spare time is cooking. I love playing around with different recipes and trying out different stuff. And I was thinking, what if I can use a graph to help me recommend new recipes that I can try? So I loaded up a data set called Recipe NLG, which is an open data set from Poznan University of Technology. Very cool, 2.2 million recipes and ingredients in them. So we put that in a graph, and now I just want to try, can we use NeoDash with this plugin to create some natural language queries and turn those into Cypher and turn it into a dashboard? Now, there's two flavors of what I'm going to do here. One is the one-shot translations, which is let's try if we can, in one shot, create a correct Cypher query based on a question. Now, you'll see that this is quite hard, but it works for some cases. And then the assisted querying, which is the kind of the step back saying, okay, maybe an LLM cannot provide me with the perfect Cypher query, but can it get me 80% of the way there? Can it do me 80% of the work for me, and I just have to tweak in the end? So if you're familiar with GitHub Copilot in VS Code, this is almost the same, right? You generate a code fragment, you need to do a little bit of tweaking, and then you've got your code written much faster. So more like an assistant rather than a completely independent tool that writes Cypher for you. So I'm gonna jump into the demo now, and I'm gonna open up NeoDash. And yeah, just FYI, NeoDash is a web-based tool. There is a free public deployment here, neodash.graphapp.io, that you can use. You can also run it locally. There's a Docker image. You can run it inside Neo4j desktop. There are many places, many ways to run it, but it's always running in the browser. And I've connected to a database of mine. So this is an Aura instance that I have set up earlier. I already loaded the data, so that's all out of the way. And when you're getting started with NeoDash, you can start adding these reports. So if I click this button here, it's going to give me a card, and this is where I can write my Cypher query. So just to give you an example, if I say, show me all the ingredients, or maybe just like 10 ingredients inside a table. I can run that, and it will read from Neo4j and give me a sample of the ingredients. So brown sugar, milk, all these kind of things. So that's the basics of NeoDash. But with this plugin enabled, it actually gives me an extra feature, which is this button that toggles Cypher to English. I'll show you this in a bit, but I just want to show you also how to set up the plugin for yourself. So when you have NeoDash open, there's an icon here on the top right, a puzzle piece that you can click. And here you can decide which extensions to enable. So here I've already turned on the natural language queries extension, and this is the one that we're going to be using. So you just have to click and toggle the button here. Then once that's turned on, there is a new button on the right here called natural language queries. And this is where I put my credentials for the large language model. So we've got OpenAI here. We also support Azure OpenAI. In the future, we also want to support Google LLM services and other things. But we're working on that. So you put your key in there, you validate that, and if everything is okay, you can choose a model that you want to use to generate the Cypher. So we've tried several, and GPT-4 is just really, really good. Well, compared to GPT-3, it's infinitely better at generating good Cypher queries. So I recommend, if you're using OpenAI, GPT-4 is a good model to use. It's a little bit slower, it's a little bit more expensive, but it's worth the quality of the queries that you're going to generate. Anyway, that's how you set that up. But now let's try it out, right? Before I try it out, I have to say that large language models are by nature non-deterministic. So sometimes they work really well, sometimes they don't. It's kind of a shot in the dark. So we're going to see if we're lucky today with the demo. But I'm going to just try something, right? So we've got our recipes, we've got our ingredients. Let's try writing, show me all the recipes that contain the word cookies. And we're going to show that in a table. Right, got my question here. I'm going to hit translate, and then under the hood, all this magic is happening, injecting the schema, the prompt engineering, where we're taking care of all of that for you. And waiting a little bit and see if OpenAI wants to give us an answer. Come on. So we are not blessed by the demo gods today. Let me try that just one more time. There we go. Great. So took OpenAI a little while, but it has thought about our question and then converted it to this Cypher query. So what did that create for us? Recipe where the title contains cookies. So this is what I asked, right? All the recipes that have cookies in the title. And then it's returning a bunch of values. So the title of the recipe, the ingredients, the ID, all these kind of things. So OpenAI has decided on its own that these are the properties that it's returning to me. I never asked for these properties, but it just saw that these are on the recipe node and figured maybe I'd be interested in them. So that's also quite interesting. If you're not specific with your questions, it makes up some stuff for you, which can be fun or sometimes can be a little bit annoying. But now we've got some recipes, right? All these recipes that contain cookies, and we immediately see the ingredients, which was a property on them, the ID, and also the steps, which is quite a long string, so it's falling off the table here. But that seems to work. Now I want to try the same thing, but with a graph visualization. So I'm gonna go again to my report, graph, and then write, show me all the recipes that contain the word cookies. Exactly the same question, hit translate and see what happens. Now my assumption here is that the model, because it's aware of the type of visualization that I'm using a graph visualization, I don't want to see properties here. I don't want to see strings. I want to see nodes and relationships. And the model has figured it out, right? I said, show me the recipe that's called cookies. It has also given me the ingredients, even though I didn't ask for that. But that seems to work. It's created a Cypher query. It looks good. One thing that models are, the LLM models are not very good at is relationship direction. So you'll see here, it actually says recipe in ingredient. So if you're familiar with Cypher, this is the syntax that we use to specify a relationship. So I'm going to have to fix this. This is a small mistake that it made because it pointed the in relationship from the recipe to the ingredient and not the other way around. So almost correct. And let's run that and see what happens. So there we go. Right, a very big graph. As I said, 2.2 million recipes, so you can expect a lot of cookie recipes. But it seems to work, right? I've got a lot of recipes here. I can click on one and we see here that this is one called Mars bar sugar cookies. And all the ingredients are also floating in the graph over here. So that seems to work. Great. So we've done a graph, we've done a table. Let's try something else. So I will try now a pie chart. And I will ask it, show me, well, actually, let's see, top 5 ingredients that are most commonly used. So I'm getting, on purpose, I'm getting more and more vague with my requests, right? I'm asking for top 5 ingredients that are most commonly used. So I'm relying on the model to figure out that usage means that it's in a recipe. So the model is actually quite smart to figure out that by usage, I mean an ingredient that's in a recipe, which is quite fun. So I'm going to click on translate again, and then we'll see if we get a nice result. And okay, what do we get this time? Ingredient in recipe, ingredient name category, value, order by value, limit 5. So that's looking pretty good. And this time it actually did the relationship direction correctly. So this is something that sometimes works, sometimes doesn't. As I said, it's non-deterministic, so we never know what happens. But I can run this now, and it's going to aggregate this information and see which ingredients are most commonly used across the recipe database. And this is flour, butter, eggs, salt, and sugar, which honestly is not very surprising because these are quite common, especially in baking. Great. So I just want to do one more, and I want to see if I can get a more advanced query working as well. So something that is slightly more complicated in terms of graph reversals. And same thing, I'm going to choose a graph type here, and I'm going to ask a graph of 10 recipes that contain both honey and mustard. So right now I'm pushing the model even further because I'm not saying that honey and mustard are ingredients. I'm letting that figure out on its own. I'm going to see if it's smart enough to figure out that these are ingredient nodes by just specifying the name, which is nice. Let's see what happens. Okay, that didn't seem to work, so let's try it one more time. And this is the non-deterministicness that I talked about earlier. Sometimes it's worth just giving it another shot. Okay, interesting. Right, so what is it doing here? It did figure out that I'm talking about ingredients, ingredient 1, ingredient 2, recipe 1 this is inverted again, recipe 1 has ingredient 1, recipe 2 has ingredient 2, where recipe 1 ID is a recipe 2 ID. Okay, that seems unnecessary, but well, whatever, let's see. R1 is recipe, limit 10, return recipe. I think this will work. Let's try. Okay, great. It's actually returning 10 recipes. It's showing the recipes, but it's not really what I want because I'd like to see the ingredients as well. So maybe I will tell it to return all relationships and see if now it's also giving me the ingredient nodes. Okay, let's see. Right. Relationship 1, relationship 2. Almost. Now it's returning the relationships for the ingredients, but it's not returning the ingredients itself. So I'm going to do a little bit of tweaking on my own here and just add these to the statement. And I'm going to fix the directions again. And now I'm going to run this. And now we've got, yeah, this is what I wanted to see. Now we've got the recipes as well as their common ingredients, right? So we've got honey and mustard as the floating connected factor in the middle here. So you'll see for more complex queries, it's working as well. You might need to tweak your question a little bit. You might need to modify the Cypher a little bit, but it's on the way there. It's getting there. And honestly, it still feels like magic even after doing this many times to prepare for today. Going back to the slides, let's see what can we conclude from this, right? LLMs are pretty good at generating Cypher queries, but sometimes they do hallucinate. They don't always provide the exact thing that you're looking for. And we saw that it's struggling with relationship direction. There's actually already a solution for this out. There was a competition a while ago. So this is something that we're going to be improving in the next version of this plugin. For more complex queries, it often provides a template that you have to modify, right? So it's generating the layout of the query, but you might need to tweak a little bit on your own. And the final finding that we found was GPT-4 using more complex, stronger models really increases the accuracy and the quality of the queries. And this will get even better soon as we will have especially fine-tuned models on Cypher generation, and that will hopefully boost the accuracy of these predictions. So very much. Good, I'm almost out of time, but I just want to show you one little bonus feature, just because it's fun to look at new stuff that we've been doing. So Neo4j released a vector index, which is used for storing embeddings in a graph database. And embeddings are really the building blocks, the language of large language models, right? So what this means is that you can now generate embeddings with a large language model and store them in Neo4j, and then use these embeddings together with your graph to do all kinds of interesting stuff. So what we've done is we've generated recipe embeddings with OpenAI. We stored them on the nodes. We created a vector index on the properties, and then we are using NeoDash right now to build a embedding-powered recipe recommender, which sounds very exciting, but honestly, it's just one Cypher query. So I'm gonna take this Cypher query here, and I'm gonna just put that back into NeoDash. Let me go all the way up and make a new tab. So put that in here. And for those of you that are into Cypher and like to hack around with queries, you can take a look at this query. We'll publish this as well online. I'm basically doing some nice tricks with APOC, calling the vector index, and also using a parameter here. So 8 lines of Cypher. It may look complicated, but it's just a nice trick to get a beautiful visualization here. So I can save this. then you will see a result. But what we really want to do is we want to parameterize this query. So we want users to choose a recipe and then show similar recipes to what we selected. So I'm going to create a new report here, parameter select, and I'm going to let my users choose a recipe title. Now, here is banana bread selected, but maybe I can choose something else. Let's say carrot cake. Carrot cake. So what's happening here? I'm choosing a parameter in the box on the right. This parameter is used inside my query on the left. Then finding that specific recipe, I'm getting the vector embedding, using the vector index to find similar embeddings, and thus find similar recipes to that recipe as decided by the embedding. So this sounds complicated, and it kind of is, but a lot of work is done by the vector index. Again, the vector index is taking care of finding the similarity based on these embeddings that represent the nodes. So maybe we can try another one. Let's do chicken Alfredo in honor of Alfredo, who made this plugin. Right, so this is a cool one. Chicken Alfredo. So we have chicken Alfredo here, and we have a lot of other recipes which seem to be sharing quite a few ingredients, right? Chicken with wine sauce, chicken and leeks. Interesting stuff. We're seeing chicken breasts as a common ingredient, which makes sense to all of these recipes. But it is quite nice that it's so quick and easy to do this kind of similarity search with NeoDash and make it interactive. So that was just a little tangent, a little bonus feature here. And again, we're going to be working with this more in the future. But the power of NeoDash really is to make this easy and very quickly make an interactive application, as we've done here. And I think that's where you can also use NeoDash for your own projects. Great, so 5 minutes left. That was it for my presentation. I hope this was interesting. I hope it made sense. If you have any questions, you can reach out to me on my email here. Also put this in the chat, and maybe we have time for a couple of questions. Let's see. Okay, great. Let's see. Questions. In NeoDash, open source LLMs, i.e. LLMs from Hugging Face, will be available in the future. Yeah, exactly. Yeah, that's possible. So we made this interface extendable, so we can add any kind of LLM provider, whether that's your self-hosted one, whether that's one from Azure. So we're really looking to extend this and make it, applicable to any kind of LLMs. Also for people that have security requirements that don't want their data flowing to a cloud provider, for example. Have you also evaluated other vector models or only the one from OpenAI? So we've tried with OpenAI so far. We're expecting that other models might be significantly better, but we haven't tried. So we're still looking to, for example, I think the Google one is next on the agenda. Okay. Why multiple carrot cake nodes? Yeah. Okay. I forgot to explain this. The database has 2.2 million recipes, but they have duplicate names. So one recipe called carrot cake, there might be 10 other recipes also called carrot cake with different ingredients that just have the same name in the database, which is why they're duplicated. So they're actually different recipes, they're just the same name. That's a limitation of the data set. And I see Alex already said it. Thanks, Alex. In GPT-3, the vectors are quite bad for searching. See, blah, blah, blah. Yeah. Okay. Yeah, maybe that's why. Maybe that's the reason why it wasn't working. That's thank you, Moritz. What else? Thank you. Thanks. I watched another session describing a rather complex process to convert natural language queries to Cypher with Cora, CodeLlama, fine-tuning metrics. In what you're showing, it seems that GPT does all the work very easily because the queries are not specialized. That's a difficult question, right? I mean, I think one of the things that NeoDash makes it look very simple because it's abstracting all this complex logic away from you, and it's not perfect, right? I've chosen these queries because I know they're likely to succeed. If you start experimenting yourself, you'll see, especially with more complex queries, that you're going to be struggling, and then you're going to need some fine tuning and more complex applications like LangChain. But this is again something that we need to look into. This is really an early access thing at the moment. Yeah, I think that's it. Thanks everybody. Again, if you want to reach out, I'll put my email address in the chat. And hope to see you at another session. Bye-bye.